So after Michael Faraday discovered that he could induce electric current in a coil of wire that was wrapped around a soft iron ring by running current through another coil of wire wrapped through the iron ring, he then decided to use just a regular permanent magnet and move it in and out of a coil of wire. So we can demonstrate that here by taking a coil of wire connected to our galvanometer and a bar magnet. I'm going to take this coil of wire, set it up like this, and I'm going to move the magnet back and forth inside of the coil. Notice the needle on the galvanometer moving back and forth. So here's the north pole. When the north pole goes into the wire coil, it deflected left, and when it came out, it deflected right. So the current is alternating left, right, left, right, left, right, left, right. So as the magnet goes back and forth, the current alternates the direction. It goes one direction when the pole goes in, it goes the other direction when it comes out. So the north pole in makes current to the left, the needle deflects left. When the north pole is out, it deflects to the right. South pole, when the south pole goes in, notice the needle deflects to the right, and when it comes out, it deflects to the left. So the south pole is making the current go the opposite direction that the north pole did. So the south pole, the current goes right, left, right, left, right, left, but for the north pole, the current went left, right, left, right, left, right. The faster we move this, the farther the needle deflects. So if we can get this magnetic field moving really, really quickly, we'll generate more current. Another way to generate more current is to use a stronger magnet. Here I have some really strong neodymium magnets. They're much stronger than the bar magnet. So when they go in and out, the needle deflects quite a bit more. So the stronger the magnet, the more current you generate. The faster the motion, the more current you generate. And the third factor that influences the amount of current we generate is the number of coils of wire. If you wrap twice as many coils, you will get twice the current for that magnetic strength and speed of motion. So in order to produce a lot of electricity, we need many, many, many coils of wire, extremely powerful magnets, and rapid motion. That will allow us to generate the most current. Now notice, current is only generated when the magnets are in motion. If I set the magnet in there and just leave it, there's no current generated. If I move the whole thing together, there's no current generating. There has to be relative motion. One or both of these, the coil or the magnets, have to be moving, but not moving together. So you can also generate current by leaving your magnet stationary and moving the coil of wire. Now I can also put the magnet on the outside of the coil, and you can also generate current, but not as much. So you'll get the most current generated when the magnets are inside the coil, or the way most of our generators are made today, the magnets are all around the outside of the coil and the coil spins. Instead of moving back and forth, it spins. So all we have to do to generate electric current is to make magnets move relative to coils of wire. So in order to solve our energy crisis, in order to get enough electricity for everybody, we just have to figure out ways to do this.